All right, in this video, we are going to start with the program. So if you are on your Chromebooks, you don't have Microsoft Office on them. So I'm going to be doing this on Google Sheets. You can either follow along on Sheets or do Excel. It'll basically be the same. So I'm going to do Google Sheets, and I'm going to start a blank sheet. And what we are going to be doing right now is create a program that'll solve or help us with the beam design when we have a concentrated load at the center. So I'm going to create, just kind of as I do it, make it aesthetically pleasing to help it be organized. So I'm going to create a little box right here and always use borders. I'm going to do all borders. I might give it a thick border as well. I'll give this top part a nice thick border. I'll merge it, and maybe I'll make it an extra one. Yeah, I think I like that. Okay, and I'm gonna call this beam loading, and I'll make it centered and bold, and I'm gonna put right here beam length followed by dead load followed by live load, and then total load, which is the P. And it is very helpful to constantly be telling yourself what units to use, especially in later equations when we are doing more complicated equations and you have to make sure that all units are apples to apples. You don't have kips and pounds or feet and inches. So beam length is typically going to be in feet. Dead load and live load are probably going to be in kips, so we'll leave it like that. Maybe you want to clean this up a bit, and that's probably good for now. Okay, next I'm going to be doing beam analysis. So I'm going to copy this over just to keep the formatting down, and then I'll delete this stuff because I only want the formatting. And I'm going to make this beam analysis. And I'm going to say the reactionary forces RA and RB, reactionary force at point A, reactionary force at point B, and then I'll say max shear, and then I will say the max moment. I will then say that reactionary forces are going to be measured in kips, and then the max moment is going to be in kip feet, sometimes in pounds feet, but we'll leave it at kip feet for now. Later, when we do the beam design for the moment, we're probably going to want it in pound feet. Okay, so that's good for now over here. And let's start programming this. So beam length is going to be a user input. User input cell should always be yellow. Dead load and live load are also going to be user inputted, so that's going to be a different color. Let's just choose a color. It doesn't really matter. RA and RB, max shear and max moment, they're all going to be non-user inputted, so they're going to be that same grayish color if that's what you chose. And let's start programming this. So the total load is going to be equal to the dead load and live load. So equals this cell plus this cell. And if you are someone like myself who doesn't like to have these zeros be present, you might want to add a little bit of logic. I'm also going to highlight the whole column and make everything centered. So I'm going to say, all right, let's add a little bit of logic. So I only want this total load to appear when I have a dead load and a live load. So I'm going to say at this cell, if this cell plus this cell equals 0, then show me nothing. So I'm going to do like quotation, quotation. If it is something, meaning it's not 0, meaning that like we're ready to execute it, then tell me this plus this. Boom. So now if this is nothing showing, it's something here. If I put something here, boom. and it works. Once you have it work, you should never touch the cell again. Okay, so when we have a concentrated load at the center, the equation for it, let me pull it back up. Where'd my thing go? So let's go back to our, over here. So then I'm going to say this is equal to P over 2. And this is equal to C6 divided by 2. And the max shear, the maximum shear basically will always occur at one of the supports. In this instance, since it's loaded symmetrically, RA and RB are always going to be the same. If they were not the same, then the max shear is going to be the max of the two of them. So again, in this one, I could have just said it's equal to P over 2, it's equal to this, but just to kind of show you how I would approach this, since a lot of times it is going to be the max of them, I'm going to say that this is equal to the maximum of these two values. Again, if you want to add logic, you definitely could. And basically, let me delete that. Basically, if the logic would be, let me backspace a little bit. What did I do? If P is not there, equals 0, then nothing. If it is there, then I want it divided by 2. Why did that not work? Because C6 is not equal to 0, it's equal to quotation, quotation. And then that's the same logic, so I'll do the same thing for these two. If this is equal to quotation, quotation, then quotation, quotation, else this divided by 2. And then same thing here. If C6 equals quotation, 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 else that. Okay, and then what's the max moment going to be equal to? PL over 4. So I'm going to say equals if, and you guys do not need to be doing the logic. I like the logic. I'm probably going to stop doing logic soon just for time's sake. But, if you can keep up and do the logic, great. If not, just get the program to work, and that's what I really care about most. Else P multiplied by, I forget already. What was it? PL over 4. So P multiplied by L divided by 4. And that gives me my moment in kip feet. So let's try it out. If we have 18 feet and the dead load is 5 and 5, boom, we have all our values. All right, looking good so far. Now, what we will be doing next is we will be doing our moment. We're going to be checking for our moment and then determining what the size beam would be needed. So over here, and you don't have to do it this way. I kind of just like to copy everything over and then delete. I just like following the formatting. So I do that and then delete. It's not a necessary step. You can do it any way you want. And I'm just going to call this moment. And for now, what we're going to be doing is saying that we're going to beef up the moment. So we're going to say that, this is just to kind of help label it for ourselves. I'm going to say that M of n measured in pound feet is greater than or equal to. There is a way to add that symbol so it's all in one, but I don't remember. Did I spell safety right? Why does it look weird? Okay. So what is it going to be? Let's just say that this cell is equal to, if I want to get the max moment, let's call this M of n actually. M of n is going to be equal to the max moment multiplied by 1.67. And we are going to want that in pound feet. So what I'm going to do is I'm going to multiply it by 1,000. And then that's going to be measured in pound feet as my torque. And if you like formatting the cells, you can always format things over here. I often like it with commas to help, but as long as the values are there, you're good. So the next thing we would then do is calculate our z of x, our plastic section modulus. So our plastic section modulus is going to be our beefed up maximum moment divided by the yield stress, which is F of y. So before I even go there, I'm going to have to kind of create another little section. Let's do that over here. And we're going to make this all about the steel and selected member values. So I'm going to call this steel and selected member values. And I'm just going to go back and unmerge everything, ruin all my formatting, it's fine. Let's do F of y, E, and then we're going to make this one. Let's merge these two cells and call this member chosen. And F of y is measured in PSI. E is, let's do PSI. So I'm going to make these, let's add borders for all of them. I want the smaller border. And then these are user inputted values. So let's do that. Okay. So now I'm ready to calculate the z of x. Z of x is measured in inches cubed. And that's going to be my moment that I did over here divided by the F of y. But remember that we have pound feet over here. And this is inches. So I'm going to have to convert this to pound inches first. So I'm going to say that this is equal to this value multiplied by 12 divided by F of y. It gives me an error message. That's because this is not there. This is blank. It's 0. Divided by 0 is an error. You can logic this out by saying if K3 equals 0, then don't do it. And it kind of gets rid of that problem. And then when F of y, which probably will be 36,000 or 50,000. I'm just thinking. Another thing we actually might want to do is we might want to make this KSI. And if that's KSI, then I'm going to make this KIP. Yeah, don't hate me, I'm changing it up. I'm going to make this KIPS. So I'm going to change this to get rid of that times 1,000. And then this is going to be 36. And then over here, perfect. Okay, I like that better. So then E is 29 million also. All right, so at this point, we now have the plastic section modulus. I'm going to clean this up a little bit just to kind of keep the formatting consistent. This is not easy to do live. There's a lot going on with this. I'm going to give this a thick border on the outside. Okay. I like that. Almost done. I'm just going to get rid of this. Great. Let's stop there, and then the next one we will continue.